So let's take a look at this picture. We've got an osteocyte boxed off. We know that it's a cell that's in an airspace called a lacuna. We know that these osteocytes were formerly osteoblasts. Osteoblasts were bone-forming cells that laid down rings of calcium salts. These rings that you can see here going around this canal in the center, these are called lamellae. I'll stick that word up here for you. Now, these rings of calcium salts, in addition to this canal right here in the center, which is called a central canal, form a unit, and that unit is called an osteon. So if you look at this set of rings, and if you look at the central canal and the osteocytes together, this unit is an osteon. The older name for it is a Haversian system, but most textbooks are moving away from that term and using osteon instead. Likewise, the central canal there in the middle is sometimes called a Haversian canal. So let's take a look at this picture. This picture has a nice view of an osteon here on the right side. We know that an osteon is a central canal in the middle and the surrounding rings known as lamellae. In the picture on the left, you can also see a central canal here in the middle, and we can also see the radiating rings going around the outside. Now, of course, that osteon is the building block, you might say, of compact bone tissue. So let's talk about what makes up bone tissue. The majority of bone tissue comes from inorganic components. Around 67% or 2/3 are these inorganic components that you see here. That includes mostly calcium, some phosphates, and some other chemicals like potassium and sodium. Now, you'll notice that the hardness of bone is coming from calcium phosphate crystals and calcium hydroxide. Together they combine to form a chemical called hydroxyapatite. Now, bone that is just containing these hardened chemicals would not be very able to support the body without the flexibility of collagen fibers. So collagen fibers make up around 1/3 of the bone's mass, and you'll notice these collagen fibers here are considered to be the organic components of the bone. So collagen provides flexibility, it doesn't provide the strength. It does, however, keep the bone from being brittle. So you need both collagen and these hard hydroxyapatite crystals to provide strength and flexibility for the bone. So we're looking for bone to be strong, not brittle, but somewhat flexible. Only about 2% of the bone's weight comes from these cells like osteoblast, clast, and cytes. So here in summary, those crystals called hydroxyapatite crystals are 2/3 of the bone's weight. 1/3 comes from the collagen fibers. Notice these important points here. Hydroxyapatite is needed for strength and support of the bone. However, collagen fibers are needed for the flexibility of that bone. You really need both of these to work together in order to provide strong but flexible support for the body. Let's talk now about 3 types of canals: canaliculi, central canals, and perforating canals. Canaliculi are tiny canals. They connect neighboring osteocytes to one another, like you see here. They also connect these osteocytes back to the central canal that's in the center of the osteon. In this picture, we're going to say that this area over here forms the central canal. I'm just going to put CC for central canal. And we know that these dark spots here are home to osteocytes embedded in air pockets called lacuna. Now, these little strands that are radiating out from the center, those aren't strands at all. Those are actually canaliculi. They're teeny tiny canals that connect the osteocytes to one another and also back to the central canal. Now, the central canal here contains a blood vessel or a nerve. So if it's a blood vessel, we're looking at nutrients and things like oxygen being radiated out to these other cells. Great picture here of canaliculi. You can see them as radiating strands coming out from the center. They're not strands, they're actually canals that carry blood to these other cells. This way, the bone can remain a living organ, and it allows us to nourish these cells that are farther away from that central canal. Perforating or Volkmann's canals actually connect neighboring central canals. So this is a central canal here that I'm circling, and over here is a neighboring central canal. This connector canal that goes between the two is called a perforating or a Volkmann's canal. In this picture, you see many osteons. Osteons are, of course, a central canal, I'm going to circle this one, and the set of rings that go around it. Okay, so there's one osteon. We can pick on another. Let's select this one down here. They call it HC, which is just another name for that central canal. It's sometimes called a haversian canal. And of course, these lamellae or rings are formed around it. So what I'm basically building here is called one osteon, and that's what they're showing us. So to connect together these central canals, like here's two central canals, we actually have this horizontal canal called a Volkmann's canal or a perforating canal. So let's review. We have teeny tiny canaliculi which connect together the osteocytes and an osteon and also back to the central canal. We also have these central canals that run up and down inside of the bone tissue. So let's pretend for just a moment. I'm going to build a really tall skyscraper, okay? And my skyscraper is going to have several elevators. So I have an elevator running up over here, and I have an elevator running up over here. These are central canals. I'm just going to abbreviate and call them CC for central canals. Now, let's say that your really tall building has major floors, hallways connecting these floors together. So like right here, let's say that this is the 11th floor of your building. When you get off this elevator here, you can walk a big hallway over here to this elevator. That type of canal that I just created is called a perforating canal, okay? Sometimes called a Volkmann's canal. It is going to run horizontal on one particular floor. Now, let's say that your office space is over here on the 11th floor. You might walk from this central canal here, down a hallway, over a hallway, and there to your room. These are our teeny tiny little canals called canaliculi. I'll just call them CAN for short. So if you think of it like an elevator with major hallways and teeny tiny hallways, that will help you understand that central canals run vertical, and the horizontal canals are, of course, our Volkmann's canals, or sometimes called perforating canals. Okay, and if you want to take, say, the 11th floor, you travel over to your office space, you're going to do so by teeny tiny little hallways. Those are called canaliculi. So this is a great picture for us to look at all the components. First of all, let's circle an osteon. An osteon includes a central canal and a set of rings. So right here is our central canal, and we can see the rings travel around that central canal. What are those rings called? They're called lamellae. And these cells that are embedded in the lamellae, they're called osteocytes. What is the name of the air pocket that surrounds an osteocyte? It's a lacuna. All right, so if I have, say, two central canals, like these two here that are connected together, there is a type of horizontal canal that connects them. That horizontal canal is called perforating or Volkmann's canal. Okay, hard to see the canaliculi here, but we of course know that they radiate out from this central canal and connect to these individual osteocytes, and they also help to connect these osteocytes to one another. Let's transition and talk about spongy or cancellous bone for just a moment. Spongy bone is in fact spongy in appearance, and you can see this with the naked eye. Spongy bone is meant to be a shock absorber, and it is also found in the ends of our bones where we tend to have a lot of weight. So it does help to absorb the friction and shock that we see at our movable joints. So let's take a closer look. We can see here that the spongy bone structure is built on trabeculae. Now that's a blank for you to fill in on your worksheet near the bottom of page 66. These trabeculae are bony bars that provide strength inside the spongy bone. There's also plenty of pockets in here. These pockets, they look like air spaces, but that's where we would have bone marrow and we would have blood vessels. So there is red marrow that may be in fact housed in the spongy bone tissue. Another look here at the trabeculae of spongy bone, and these open spaces would in fact house either red marrow if you're making blood cells, or yellow marrow if you're simply storing energy.